carry on with 11.1. This is question 9. I've got to convert the following volumes into centimetre cubes. Right, so imagine, what is a metre cube first of all? This is going to be fascinating. Well, that's me trying to draw a cube that goes a metre across, 1 metre high, and 1 metre going into the screen, as we can see. So basically I've got 1 times 1 times 1 equals 1 metre cubed. Now you also know, I'll try and draw this same sort of thing, that they're meant to be exactly the same, but anyway, you know that a metre is 100 centimetres. There's 100 centimetres across, 100 centimetres going into the screen, and we've got 100 centimetres height there. Alright, so what is 100 by 100 by 100? Well, I've got 1 followed by 6 zeros. That is 1,000,000 centimetres cubed. So really, 1 metre cubed is equal to 1,000,000 centimetres cubed. You wouldn't believe that had I not done the calculation, but it's true, because you know 1 metre is 100 centimetres. So how do I change metres cubed into cubic centimetres or centimetres cubed? Simple, you multiply the metres cubed by 1,000,000. So that's going to be, if I multiply this by 1,000,000, 1, 2, 3, 4, 5, 6, I'm going to get 8,000,000. 1, 2, 3, 4, 5, 6. What about the 3.2? I'm going to get 3.2 million. So 3200, then 000. Look, bam, bam. See, 3,200,000 is 3.2 million. This one, 765. Just move the decimal point across 6 times. 1, 2, 3 takes me this far. 4, 5, 6. So 0.765 meters cubed is 765,000 centimeters cubed. I ought to put centimeters cubed here for completeness, hadn't I? And this one. Now, last one, still multiply by 1,000,000. That'll be 5, 6, 8. I've gone 1, 2, 3, 4, and of course there's 2 more zeros to come if you multiply by 1,000,000. Again, you can use your calculator in Unit 3, so if you're not sure, just put that into your machine and multiply by 1,000,000, and we'll see what we get. But I'm sure that's correct, and that will be centimeters cubed. Right? So I'm sure that's quite fascinating, that a metre cubed, which is quite big if you think about it, a metre sort of that big, and a centimetre cube is a titty little sugar lump, if you know what sugar cube looks like. So you get loads of them in a whole metre cube. Next question. I like this question, it's really interesting. It's got a little yellow triangle with a red asterisk in it. In other words, it's meant to be scary. Alright, so, but it's not. It says a 25 millimetre square hole is cut right through the centre of the cuboid. Please note it's square. Find the volume of the remaining cuboid. In other words, you work out the great big green block there, and then you work out the block that's been chiselled out and take it away. So imagine there's fresh air in there and there's nothing there, you can just wiggle through and maybe get your finger through the other side, I don't know. So what have I got here? If it's 25 across, it must be 25 millimetres high, and it goes in all the way back 9.5 centimetres. But look, we've got mixed units, okay? Now these are all given in centimetres, and that's given in millimetres. So let's just change it into centimetres, others will be in big trouble. So that'll be 2.5 centimetres, alright? You know there's a 10 millimetres in a centimetre. So what have I got to do? I've got to work out the volume of the big green block, then take away the volume of the 2.5 by 2.5 piece of wood that might have been there originally. Here's me assuming it's wood, I don't know. But anyway, essentially I need to do this. 9.5 centimetres by 9.5 centimetres by 8 high. Let's get the answer for that bit. So 9.5 times 9.5 times 8, bam, I've got 722 centimetres squares. Now this little bit here is going to be 2.5 times 2.5, that's at the front, and don't forget it goes all the way back here, alright, so it's also 9.5, so times 9.5, let's do that now, 2.5 by 2.5 by 9.5. That gives me 59.375 centimeters. Sorry, that should be cubed as well, shouldn't it? Now, what do we do now? We now subtract to get the final volume. May as well call it something special rather than just a volume. All these are volumes, of course. So the final volume is going to be this subtracted, that subtracted from that. So 722 take away 59.375 gives us 662.625 centimeters cubed worth of remaining wood. All right. Let's just round it off to one decimal place, 2 decimal places. That's about 662.63 centimeters cubed. That'll be good enough. Right, it's question 10. And next one is, I rarely do these the problem solving ones, but I thought it's interesting because we got 3D shapes, geometry, shape and space mixed in with algebra, so I rather like that. By the way, the unit is of course algebra and geometry, so they're allowed to do this. Do these cuboids have the same volume? Well, how do you work out the volume of a cuboid? It will be width times, I don't know, or length times width times height. It doesn't matter what you call it. You must multiply the 3 lengths that are pointing the 3 different directions to make the 3 different dimensions. So I've got 10x multiplied by 9y multiplied by 4z. Well, that is 90 times 4. 4 9s are 36. So I've got 360 x, y, z. Please note, no times is. I only did that to show you I'm working out a volume by multiplying the 3 relevant lengths. Okay, so 10 times 9, 90. 90 times 4, 360. X times y times z, x, y, z. Okay, tighten up a bit. Now, what about this here at the bottom? I've got 6x multiplied by 5y multiplied by 12z's. Lovely. Well, let's just do this. So I've got 6 times 5 times 12 equals, oh my goodness, there it is, 360 x times y times z, x, y, z. So what have I got here? The volumes are the same. There's no further discussion. You just sign it off as done because you've proven that that is the same as that. If you want to show a few more steps, well, don't bother really. You've proved that that's 360 xyz and that's 360 xyz. You've shown that you've multiplied the 3 relevant lengths, so it's time to stop, and that's good enough. Okay, so that's that, and that's the assess. No, it's not. That's chapter 1 done of chapter 11. So part 1 of chapter 11 done, and we'll look at 11.2 quite soon.